Alright, so today we're going to talk about a few different types of factoring. We'll go through two examples for each different type that we discuss, and we'll also talk about different types. That way you can apply the techniques that we learned today properly. Okay, so in algebra, particularly in Algebra 1 even, you start to learn factoring, and you learn it with a particular type of quadratic equation, like this guy over here, c squared plus 7c plus 10. So in Algebra 1, you'll learn how to factor these, but then you stop. You don't go on to more complex algebraic expressions like this one over here that has 4 terms. And some algebra teachers teach this in Algebra 1, others don't, but you also learn how to do quadratics that have an a value or an integer in front of the squared term. So what we're going to do is we'll start by reviewing how to factor regular quadratics like this, and then we'll talk a little bit more about some more complex equations that most students encounter in Algebra 2. Okay, so these are the three that we'll be talking about: regular quadratics, difference of square quadratics, and then slide and divide quadratics. So first things first, in regular quadratics, we want to learn how to recognize them. And the reason that we want to learn how to recognize them is because we use different techniques for different problem types. So if we use the wrong technique, even if we know how to do the technique properly, if we use it on the wrong problem, well, no gain. You have to use the proper technique. Okay, so regular quadratics have 3 terms. One has to be a squared variable. One is a regular variable, meaning a variable that has an exponent value of 1, or an unwritten exponent. And then we have a lonely digit, i.e. a number that doesn't have a variable attached. Also, there cannot be a number in front of the squared term. We'll look at these 5 examples down at the bottom, and we'll walk through each of those ideas. First one, x squared plus 15x plus 24. Okay, it's got a squared term. It's got a regular term, a variable with an unwritten 1. That's good. And then we have this lonely digit over here, no variables attached. This qualifies as a regular quadratic. We're good to go. 9x squared minus 1, however, does not qualify. And the reason is it only has 2 terms, 9x squared and then negative 1. We have to have 3 terms to do our regular quadratic factoring technique. So this one, out of the running. M squared plus 17m plus 72. Let's go through the things that we're looking for. Has to have 3 terms, which we've got, m squared, 17m, and 72. The first term is squared, perfect. The second term is just a variable attached to a number, that works great. And then we have 72, that works great. Same thing with b squared minus 22b plus 120. This one qualifies as a regular quadratic as well. The fifth one, however, does not. So if we look at this, we've got a 6 in front of our r squared value. Remember, we can't have a number in front of the squared value unless it's an unwritten 1, as in the previous examples. So this one is out of the running, even though it has 3 terms. Okay, so let's take a look at how to do them. So your first step is to identify what your answer should look like, and it should look like this. You should have a variable. In this case, it's an x because our original problem has an x, but it could be another letter depending on what your original prompt had. I want to add or subtract to each of these variables, and I separate them by parentheses because we would actually multiply these together to get the original equation. Okay, so that's what our answer should look like, and of course we'll show you the final answer here. First thing you do, I like to circle the last term and then write out its factors. So I write out all the numbers that multiply to be positive 24. In this case, I know it's positive 24 that I'm aiming for because there's a plus sign in front of the 24. The next thing that I do is I'm going to rewrite all of those factors with a plus sign instead of a minus sign in between them. And then I add them together. So there's the plus sign, I added them together, and now here's the second to last step. I look at the middle term in the original equation and I try and match it with the sum of 2 factors. So these 2 factors, 2 and 12, add together to be 14. So that's great. So that'll be important when I write my final answer. So once I've matched the factors with their sums in the middle term, I can write my final answer. I pull down the 2 factors that add together to be the middle term, and I write them in the answer format that I originally pointed out in the previous slide. So the final answer here is x plus 2 times x plus 12. Okay, let's look at another example. So b squared minus 22b plus 120. First step, just like the previous problem, I'm going to circle that first term, and then I'm going to write out its factors. So 120, positive 120, has a lot of different factors. And if when you first start to do these problems, you struggle to find all the different factors, know that you're not alone. This is definitely one of the hardest part of factoring regular quadratics, and many students struggle with this. Many students in particular forget that two negative numbers can can multiply together to be a positive number. So be sure to include all the negative factors, even if the value you're trying to find the factors of is positive. Okay, so we've got all of our factors. There are a bunch of them there. Then I'm going to rewrite the factors with a plus sign in between them. I add them together, and once again, I try and match my middle term, negative 22, with a negative 22 down here. So it's the very last row of factors here. So my answer is going to be the two factors that add together to be negative 22. Okay, so let's zoom in on that. So my final answer, I'm just going to pull down that negative 10. It's going to go right here, and the negative 12, it goes right there, and there's my answer, x minus 10 times x minus 12. Okay, so those are regular quadratics, and of course, feel free to go back and review those slides if you didn't catch the technique the first time around. It's all about practice. Okay, next thing we're going to talk about are simple difference of square quadratics. So they've got two terms, one with an even exponent. All my examples down here at the bottom, with the exception of a to the third power, have 2's as the exponents. But remember, it could be a 4, it could be a 6, it could be an 8. The examples that I'll use today only have 2's because they're a little simpler to understand if you're first learning the technique, but just keep in mind that you can have other values as exponents as well. The other term, typically the non-variable term when you first learn these problems, can be any perfect square. So a perfect square means that if you were to take the square root of the number, you would get an integer. You wouldn't get a fraction and you wouldn't get a decimal. Also, the two terms have to be separated by a minus sign or a negative sign. That's pretty important when we do the factoring. Okay, so let's take a look at these 6 examples down here, and we'll go through and classify them. All right, so the first term in a squared minus 49, it's squared. It has an even exponent, so that checks out. 49 happens to be a perfect square. If I was to take the square root of it, I would get 7, so that's perfect. And the two terms are separated by a minus sign, so this one works. It's a difference of square quadratics. The next one down, x squared plus 4, does not work. Although we do have an even exponent, and 4 is a perfect square, if I take a square root, it would be 2. The two terms are separated by a plus, so this one's out of the running. K squared minus 121, however, does work. It's a difference of square problems. My even exponent, I've got a negative sign, and 121 is the same thing as 11 squared, so that works. Same pattern over here with p squared minus 144. Even exponent, negative sign, perfect square. This one, a to the third power minus 64, does not work. Not for the technique that I'm about to show you. So it does not have an even exponent, so it's out of the running. And then the next one down, it does work. So some students would initially say no because the variable comes second. It's the second term, but that's actually okay. The important thing is that we've got a perfect square. 1 is a perfect square, and that our variable has an even exponent, so that works, and they're subtracted by a negative sign. The order of the two values doesn't really matter. Okay, so let's do a practice problem. So first one, a squared minus 49. The first thing that I do is I'm going to identify what I want my answer to look like. So it's going to be a variable plus a number and then a variable minus a number. And these two numbers, by the way, will be exactly the same whenever you do difference of square problems. Okay, so first step is square root of both terms. So go ahead and do that. I'll take the square root of a squared and the square root of 49, and then I write those values down. So the square root of a squared, of course, is a. Square root of 49 is 7. Then I'm going to place those values into the proper format that I've identified down here. So I've got a plus 7 times a minus 7, and that's your final answer. So difference of square problems, they go pretty quickly. All right, another example. We're going to do the same thing. We've already identified what we want our answer to look like. And now I'm going to take the square root of d squared and the square root of 100. I'm going to write down what those square roots are, and then I simply place them into the proper equation format. So my final answer, d plus 10 times d minus 10. All right, third and final technique that we're going to talk about are slide and divide quadratics. So we have to have 3 terms, very similar to regular quadratics in that respect. One squared, one with just a single variable with no exponent, and then one lonely digit with no variable attached. However, the big difference between these and regular quadratics, and I'll go ahead and zoom in on it, is that there should be a value in front of the squared term. So we can go through these different samples and we'll identify whether they fit our criteria or not. Is this one a slide and divide quadratic? Yes, it certainly is. It's got 3 terms, and then there's a number in front of the squared term, so that works. Same thing with 2b squared plus 17b plus 21. This one fits as well. 3 terms, 1 squared, 1 not squared, 1 without a variable, and then there's a value, a number in front of the square term. Perfect. What about the third one down? No, it does not work because, although it does have a squared term, a regular term, and then a number without a variable, it does not have a number preceding the squared term. 7k squared plus 9k, that one does not work because there aren't 3 terms. X squared minus 16x plus 63 does not work because there's no variable, or excuse me, there's no number preceding the squared term. And then this one, 7x squared minus 32x minus 60, does work. It satisfies all the criteria that we're looking for. 3 terms, 1 squared term, and then a value preceding the squared term. Okay, so now you know how to recognize them, so let's do an example. So slide and divide quadratics have a bunch of different steps, but the steps individually aren't particularly hard. It's just remembering to do them in the proper order, and of course, that takes practice. Okay, so first thing that we do is, once we've recognized that it's a slide and divide quadratic, is I take the first number and I slide it on down and multiply it to the last term. So I'm going to multiply 21 by 2, and then I'll rewrite my equation. So now I've got b squared plus 17b plus 42. This 2 value, it just disappears after you multiply it down, but it's not the last time we'll see it. Okay, next thing you do is you treat it just like a regular quadratic. So I'm going to circle 42, and then I'm going to write down its factors. So don't forget the negative factors as well. Those are important. And then I'm going to add those factors together, and I'm going to try and match the middle term of the original expression with the 2 factors that add together to be 17. And then I can rewrite these values, 3 and 14, into a regular quadratic answer key format. So once I'm there, you would think you'd be done, but we're actually not quite done. So remember that 2 value that we multiplied in originally? Well, we still have to get it out of the equation in our current answer format. So the way that we do that is we divide both of our numerical values in our answer choice by the original value that we multiplied in. So I'm going to divide both 3 and 14 by 2. And then I reduce those numbers if possible. So 14 divided by 2 is 7, so I'm going to rewrite it as 7. 3 divided by 2, I'll just rewrite as 3/2 because it doesn't reduce. So now, after I've reduced the fractions, if there's still a denominator in the numbers, then I'm going to pull that denominator out. So that 2, I have to bring it out in front of the b that's within its parentheses. So my final answer here is 2b plus 3 times b plus 7. Okay, so let's do another example, and we'll use exactly the same steps. First thing I do, I take my first term and I multiply it to the third term, and then I rewrite my equation. So I've slided it down, and then I'm going to write down all the factors of negative 90. So there are a bunch of different factors here, and then I'm going to change those multiplication signs to plus signs, and then I'm going to add them together. Now I match positive 89 with positive 89. These 2 numbers must be my answer choices. So I'm going to write those in. And once I have those 2 numbers, I divide them by 10 because I originally multiplied by 10 in the first step of the problem. And then I reduce those numbers if at all possible. 1/10 does not reduce. 90 over 100 reduces to 9. Now I've got this term, my 10, in the denominator of these values, so I'm going to have to pull it out in front of the variable within its parentheses. So my final answer then is 10m minus 1 times m plus 9. Okay, so those are slide and divide quadratics, and that's all we're going to talk about. So if you need any help with additional quadratic problems, any factoring, or really any math struggles that you might have in and out of school, feel free to contact us at Georgetown Learning Centers at any time. If you're in the McLean area, we've got our contact information for that office listed right here. Same thing with Great Falls and Charlottesville. So feel free to reach out if you need any help.